So I'm Philippe. I lead the development of IBCRS at Informal Systems, and that's a library that implements the IBC protocol in Rust. So I work a lot with the standard and have opinions on that. So we'll talk about that today. Right. So we'll take a brief look at the state of the IBC standard today, the challenges with the relayer substandard, and then I'll offer a potential solution, and hopefully that makes scaling IBC easier outside of Cosmos. So a quick reminder of IBC. So IBC is a protocol that enables you to send messages across chains. I think, given the previous talk, I don't think I need to go over that. Yeah, so what did the, oh, that was a GIF, so that's unfortunate. But yeah, so what did the IBC standard do right? So the core protocol, I think, is very well fleshed out. This is a bunch of substandards, ICS, whatever, that define how chains are supposed to talk to one another, what's a client connection channel, what's the structure of a packet, and so on. That's been very well, it's the core protocol, and it's been very well defined. So that's good. Clients, similar thing. Where do clients fit in the standard? We have a bunch of different clients, like the Tendermint clients, maybe the most used right now, but Polymer teams bringing new clients to the scene. So that also is very well fleshed out. Similarly for apps, we have a bunch of apps where they fit in the protocol. That's very clear. The downside of the standard today, which I think hurts our ability to expand beyond Cosmos, is the relayer standard and standardization in general of relayers. So ICS 18 is the relayer standard, and I took a screenshot of part of the standard, and it's quite wordy. It's mainly like hand-waved away, and what you should do is unclear, and it's sort of evolved, but it's never really been standardized. And I think, yeah, standardizing this is key to properly expand and outside of Cosmos, and we'll go into the details of why I think that is. So yeah, that's basically what I just said. Yeah, so that's also a gift, unfortunately. So yeah, let's do a quick refresher on relayers before we deep dive into the specifics. So in this scenario, we have chain A and chain B. We have module X on chain A, module Y on chain B, and let's assume there's already a channel between the two chains. So we're able to send packet on that channel. We're going to focus on the relayer, though. We usually don't talk about the relayer. We just say the packets get sent, but that's not actually what happens. There's an off-chain process that's doing a lot of work. And so in this scenario, let's say chain A sends a packet. What happens? Well, the relayer receives a send packet event in 1, and then says, OK, well, now I need to craft in 2 message receive packet that's going to be sent to chain B. And essentially, this says, tell module Y that there's a packet from module X and process it. So chain B is going to do that, and it's going to emit a receive packet event. So I'm done processing. Here's my response, right? And the return value that we call an acknowledgement, it's really the return value of the processing, is in that receive packet event. There's more than one event, but at this abstraction level, we'll just say there's one. And yeah, and finally, the relayer picks that up and said, OK, well, I need to tell chain A that the message was processed and what the return value is, the result of the processing. And that's the message acknowledgement. So maybe to make this more concrete, if you send tokens, so module X, module Y would be the transfer module. There's a token transfer on chain A, and then let's say on module Y, for some reason, the transfer fails. It is rejected. Well, the tokens were escrowed on chain A, and so the user doesn't have access to those tokens anymore, but the send, for some reason, failed. So you need that acknowledgement to say, it failed on the other end, unescrow the tokens for the user. Yeah, so that's when things go well. actually, a lot of times they don't. There's WebSocket connections issues, and there's bugs in software and whatever. So some of these packets get missed. So what one strategy that relayers employ today is every once in a while, I'm going to query the chain A, and I'm going to ask, give me all the packet events that all the packets you're still trying to send. I probably missed those. Just give them to me again, and I'll relay them. And yeah, the chain A then gets that list back to the relayer, and then they can be properly relayed. This right here, this interaction is not standard, and well, it is currently tailored also to Comet BFT-based systems, where Comet BFT is a fork of Tendermint Core, so SDK-based chains. And yeah, we'll dig a bit more, but essentially, because this is not standardized, relayers today don't work out of the box with chains outside the Cosmos ecosystem, and yeah, let's try and fix that. So yeah, what are the challenges with standardizing queries? If it was so easy, we would have done it. So obviously, I'm not the first to bring this up. There's already been some work towards that. If you dig in the IBC Go repository, you'll find some gRPC endpoints there that today's relayers use, and it is definitely a step in the right direction, but it's incomplete. Because, well, first, it's not in the IBC standard repo, and so people who don't dig in the IBC Go repo or don't know how to do that, they won't find it. And also, not all queries that relayers need are exposed by IBC Go. And yeah, I'll try and dig a bit to give an intuition of why that is. So we have the typical SDK chain looks like this on the left. There's Comet BFT running, doing the consensus, and through a BCI interface connects with the app in Comet BFT, and usually you'll have a Cosmos SDK framework there that developers just implement a few modules on Cosmos SDK, but mainly they all work the same because they all use the Cosmos SDK. And IBC Go is one of those modules. And so today's relayers, like on the right, they're going to talk to the currently standardized, quote unquote, in that IBC Go repo, gRPC query endpoints. And for whatever is missing, well, they'll use the custom, if you want, RPC endpoints by Comet BFT. So Comet BFT exposes some query endpoints, and the relayers just talk to that for whatever's missing. And to give an intuition of why IBC Go can't currently expose everything, so this example we gave before where I want to query the events that I missed, in this system, the events are stored in Comet BFT. But the gRPC endpoints that we talked about that were sort of standardized are exposed by IBC Go. And the app, IBC Go, only stores the hashes of packets for optimization purposes. So it does not have access to the events. So it is not able to expose a query endpoint. The specifics don't matter. The point is that the relayers today need to know about Comet BFT, and that means that the relayer software, again, cannot scale outside easily or without specific work. So the first thing to do to solve this problem is we need one set of gRPC query endpoints that cover all the queries that today's relayers need. That's the first step. And to give an intuition of how that would work with all SDK chains, is you could have, and this is one of many ways to do it, you could have some new process that we call something, and that question mark there, and the relayer only interacts with that question mark, and through this common gRPC interface, and then that would just know how to forward queries either to IBC Go or to Comet BFT, and yeah, the key here, why that's different from the previous picture, is that the relayer does not know anything about Comet BFT, and so you can just implement a new for Ethereum or whatever other consensus mechanism that you want to use, and the real layer software does not need to change. And so you don't need, as a maybe Polymer, you don't need to go talk to the Hermes team, hey, could you like modify your real layer so that it can work with Ethereum? It won't need to. So that is, it's like a decoupling that would enable scalability. Yeah, so that solves one of the problem. The other is, what about future queries? And what do I mean by that? Well, the IBC standard is constantly evolving. Polymer actually is one of the ones who doing great work there. Like anything in software, things change all the time. And so we're going to have future queries. New apps sometimes require their own set of queries. So the challenge with few queries that we don't have today is, well, first, the query system needs to be continuously updated, as I just described. The design of new queries is not clear from the start. So that's true always in software. You start something, you have an idea of a design, and then it turns out, with experience, that's not quite how you would have done it, and you refactor or whatever, and then you end up with something more stable that over time. But yeah, eventually, though, you want to be able to freeze the format of queries so that people can build on top of it. And for Rust developers out there, you might see a resemblance with what Rust had to deal with. Actually, they dealt with the exact same problem. So in Rust's situation, the language needs to be continuously updated. The design of new language features is not clear from the start. And Rust eventually wants to freeze those language features so that people can write programs using them. So I think we can learn from what Rust did and bring that to IBC. Yeah, so let's look at how Rust did that. Again, I like the GIFs, but we don't have them here. So Rust really has two different compilers of interest to us, the stable and the nightly. And again, that's always in how do you deal with this experimentation goal that you have with new features. So the stable compiler is what you were used to. So it's code compiled with this compiler is guaranteed to compile with future versions of the stable compiler. All that means is you write a program today, you download the new version of the compiler, your code is still valid, right? That's what you expect. But to enable experimentation, they brought in a nightly compiler. And this can make use of unstable features that they call. And those are not guaranteed to not break. So they could break. So if you make use of unstable features and you download the new compiler, your code might break. So just a quote from the Rust C dev guide, code that works and runs on stable should mostly not break. Because of that, we don't want to release a feature to the world with only team consensus and code review. We want to gain real-world experience on using that feature on nightly, and we might want to change the feature based on that experience. And again, I've been saying it over and over, but that's the same situation we have with IBC. So let's learn from that. So what do they do? So I'm a compiler developer. I want to implement a new feature. What do I do? So the simplified version is I open a tracking issue on the GitHub repo. And that's where all the discussion about the feature is going to happen. And then I can open a PR that implements the feature, get it merged in, and there you go. Congratulations, you now have an unstable feature. But it's not available to everyone yet. It's only available in the nightly compiler because we want to experiment first. So for some period of time, and that's left undefined, people are free to try out the feature and discuss it on the tracking issue. So that's the experimentation part. And the period of time is very subjective. It'll be on a case-by-case basis. But after a while, you eventually want to standardize it. So what do you do to get that into the stable compiler? Well, you start with a stabilization report. So it's basically a summary of what happened. The threads can be very long, but so you say, here's where we started. We had all these other PRs that fixed a bunch of issues, and there were these outstanding issues that people were not sure about. This is the stance we're taking on those. Can we please stabilize this? So the compiler team is going to take a look at this, and if they agree, the final comment period is initiated, and that's basically speak now or forever hold your peace. If you don't comment, it's going in the stable compiler, and it's there forever almost. Yeah. So. There's no magic there. It's really just a process that formalizes the experimentation phase that we all know is going to happen. So yeah, let's try and bring that to IBC, and it's a fairly simple, it's basically the same process. So we would have stable queries and unstable queries. So those stable queries are the ones that are guaranteed to not change, and maybe the semantics we have with those is a compliant IBC relayer would implement all the stable query endpoints, and same for chains. And what that means is, well, if you do implement all these query endpoints, you can pick up any relayer, and it's just going to work. No matter what your backend consensus engine is, it's just going to work. And then you have these unstable queries, and this is for the new features, the changes to the core protocol that we talked about. Those you'd probably, like in practice, you'd probably go to one of the relayer teams. I have this project, this idea. Can you like implement this feature, and you're going to need these queries. Once you have this agreement with them, and you can maybe post it to the standard repo, and it's going to be an unstable feature. People are going to know about it. They can discuss it, and so on. Yeah, so it's fairly similar. So basically, I claim that the queries used today should be stable because we have years of experience with them. And then when you want a new query, you open a tracking issue, same thing, so that there's discussion somewhere, and you can point to the relayer maybe that implemented that query so that people can try it out if they want. And then after a while, when you want to stabilize that unstable query, basically follow the same steps as in Rust. Open a stabilization report, final comment period, maybe tell the relevant stakeholders, we're about to close that, are you good with this? And then if it is, then yeah, it then becomes part of the official IBC standard. And that's a gift that does not work, but it's a that's all, folks. So that's my suggestion. I think it's a proposal. I'm happy to take comments and yeah, see what people think. Thank you.